To pick up from example 3, example 4 asks us to determine how the outlier affects the mean, median, and mode of the data. So I'm going to do this and kind of break this down into two ways. I'm going to first find the mean, median, and mode with the outlier, and then I'm going to do the same thing without the outlier to compare how it changes. So with the outlier, we can see here, I find the mean by adding up my data points, which includes that 200 value, and dividing by 7 to find a mean of 62. Now if you look at that, that mean is supposed to represent that middle point of your data, but if you look, it's not a hugely accurate description. It's a little high because notice I've got a bunch of values, 20, 30, 30, 35, that are much lower than that average of 62. So interesting that that outlier has now pulled that value up, right? If I find the median, if I list these in order from least to greatest and find the middle number, I'm going to find that my median is 35. My mode is 30. I've got two 30s that are repeated. Then I'll do the same without the outlier. So I'm going to take out that value of 200 and now find the mean again. So add up those data points, not including the 200, and now I'm going to divide by 6. There's no longer 7 data points since we took out the Galapagos turtle's lifespan. And I would find that the average is now 39. What a big difference from our 62 that we found with the outlier. Then I'll line up my 6 data points and find that middle number, which is going to be 32.5. And then I'll find the mode, which is 30 because there's still two 30s that are repeated here. Okay, so I can see when looking at how my outliers affected it that the mean lifespan decreased by 23 years. So the difference between 62 and 39 is 23 years. The median lifespan decreased by 2.5 years, and the mode did not change at all. And example 5 is going to ask us exactly what these changes mean.